Hi everyone, Nevada Virtual Academy is here trying to get better, to get smarter, to find a way to factor trinomials. I'm looking at this problem in here. First thing, like I said, look for common factors. There is none. 20, 13, 2. M, M, and N, no way, right? Perfect square. Well, to be perfect square, I need to have the first and the last term, first of all, squared. And I mean perfect squares, and they're not perfect squares. What else can we do, right? One way is to think about let's see, think about grouping, right? If I can break this 13 13mn into two into the sum or difference of two numbers in such a way that I will be able to group them two by two, because obviously I will have four terms in here, and I'm looking at it. If I have let's see, 13 written as what? 8 plus 5, 8 8 plus 5, 8 4, I don't know, let's check that. So how about writing that 13m as 8mn plus 5mn, and I will have plus 2n squared, and here 20m squared plus that. If I will group the first two, what is the common factor? 8 and 24, right? 4m squared mn. 4m, if I will divide 20m squared by 4m, I will have 5m plus 8mn divided by 4m is going to be 2n. Looks good. Plus here 5mn, 2n squared, the common factor is what? N. And I will have n times 5m, because 5mn divided by n is 5m, plus 2n squared divided by n is 2n. And I got it. Looks like it worked very quick. Common factor will be 5m plus 2n times 4m plus n, and you are done by this method, right? Now, other methods that you should try, well, let's see. I'm looking at my, trinomial here. If this is not prime, I will definitely have, a number in front here, a number, I mean, first term in the two binomials, nothing else but what? Coefficients of my 20m squared. There will definitely be an m, there will definitely be an m here, because everything is positive. I can tell you with certainty that everything is going to be positive in here, because I have an n squared, I will definitely have an n, I will have an n. So my concern now is not in regard to m and n, but in regard to what's going to be the first term in each one of them, right? So let's erase. I need only my 20, and I need only my last number here, which is 2, right? So for the last one, it's very easy. There's no other way except to write it as what? 1 times 2 or 2 times 1, because both have to be positive. Now for the other one, 20. I can write 20 in many, many ways. One way will be 2 times 10. Other way, 10 times 2. Other way, 4 times 5. Which other way I have? 5 times 4. I have 20 times 1. What else I have? I have 1 times 20. Is there any other possibility? 2 times 10, 10, 4, 2, 2, 2. I mean, the easy way to find that is basically to write 20 in prime factors. 20 is what? 2 times 2, which is 4 times 5. So obviously I have only combinations of these three terms here. And we have all of them, right? 1, 2, 3, 4, 5, 6. You have combinations of 3 taken 2 at a time. That's what? 3 factorial over what? 2 factorial times 3 times 1 factorial. Hold on. 3 factorial times, yeah, times 1 factorial, which is basically 3 is what? I think I put it wrong in here. Hold on. Combination of 3 taken 2 at a time. will be what? 3 factorial over 3 minus 1 factorial, right, over 1, which is actually 6, so that was wrong. Okay, now I'm looking at the possibilities in here, and what do I have? I mean, basically I can go with either one of these two of this first number in here as the first term, and then the other one is going to be the first one over there. So let's try that. Let's try 2 and 10. So if I will put 2 as the first one, 10 as the first one over there, I'm looking for something that will give me 13 as the sum of the products of, because these are the first two terms. If you go with the FOIL, the first two terms are getting multiplied. Then you have to multiply first one by the last one, which are the outer terms, right? But for the last one, we need to find what will be the coefficient, right? And I'm just thinking about, if I'm multiplying 2 times a number, then I have whatever in here, and I have to multiply the inner terms. If I multiply it by 20, if it will be 2 in here, multiply by 20 is going to be 20. It's going to be too big, because 20 plus 2 is going to be 22, not good enough. So definitely I should have a 1 in here, and I should have a 2 over there. But 2 times 2 is 4, plus 10 times 1, 1 is going to be 14. So this is not good, okay? Try the other way. We said it, the other way is not going to work either. So this is not a good combination. How about switching places in this case? How about putting 10 first? And hold on, because I erased everything. How about putting a 10 m and m? I need a 2m over there, right? And then let's see what combinations I have. I can have a 1 in here and the 2 over there, but then I have 10 times 2, which is not good. So I should use 1 in here and 2 in here for one of this 1, 2, 2, 1, right? And let's see what I have. 10m times 2m, which is the product of the first, is going to be 20m squared. I'm good. 10m times n is going to be 10mn. And then I have 2 times 2, which is 4m, again, not good. So this one doesn't work. Looks like a combination with my 2 and 10 does not work. You're going to try the other one. Okay, the other one. Well, obviously we know what the answer is. I'm going to try the 4 and 5, right? 4 and 5. So how about having a 4 in here and the 5 over there? Let me take that 2 off. Okay, so I will have a 5m, and then I'm looking for possibilities. And if I'll have 4m and I have an n here, let's use 1 here and 2 over there, which we know is the answer. And that's what it works, right? 1 and 2, right, is here, and this is the possibility of factoring this trinomial. We have already solved it by using the other method. Okay, and this is it. Yeah, here with the combinations, which tells me how many pairs I should have. You have combinations of 3 taken 2 at a time, which is what? 3 factorial over 2 factorial times 3 minus 2 factorial, which is 1 factorial, right? Is that right? Which equals what? I have 3, which is 1 times 2 times 3 over 1 times 2, but this is only 3. I think we should not use combinations in here. Where is it? I lost it. I think we're talking about order. Oh, hold on, because in combinations, right, in combinations, order does not matter. Where in this case here, order matters. You're looking for arrangements of 3 taken 2 at a time, which is combination of, you have 3 factorials over 3 minus 2 factorial, and that will give you 6. Okay, never mind. Because order does not matter in our pairs here, right? So I have to use either 2 times 10 or 10 times 2. They're not the same. They don't matter in the same way, and that's why we have it. Okay, Well, this is it, you know, another way to factor a trinomial by two methods here. Thank you.